right. Good afternoon, everyone. Thanks for staying for the final session. Big thanks to the organizers, Ken, Davide, and Minkyung, for organizing this amazing conference. I've been part of the program committee over the past few years. It's my first time being here, and I have to say it's as great as advertised by my colleagues. The paper I'm going to be just introduce myself. I'm Omid Rafieian. I'm a faculty at Cornell Tech. And this paper is a joint work with Mohammad Musaffa, who is a second-year PhD student at Cornell Tech. And he's the main driver behind this work. He's responsible for all the technical work here. And Heima Narasimhan at University of Washington, who I think is a new introduction for this crowd. So in this work, we're going to do exactly what the title suggests. So it's a paper about visual polarization measurement using counterfactual image generation. I have to clarify a lot of things, but that's kind of like what it's. So let me start by giving you an overview of political polarization. Gilman sets up this motivation for me really well. We all know that political polarization is a central issue in American politics. 3 out of 10 Americans named polarization as a top issue facing the country. And when asked to describe the current political climate, the term divisive was the most frequent response, and terms like polarized and partisan were also among some of the most common responses. So overall, it seems like one of the few things we are not polarized about is that we are polarized. So the research on polarization, the majority of they use textual information in verbal content to provide some measures for polarization. It could be through citations to different think tanks. Some of the first measures, the first one of them we're going to use later in this work. Or another stream of work, which is pioneered by Matt Jensko and Jesse Shapiro, is usually it focuses on the partisan use of language and framing. So for example, if someone uses death tax versus estate tax, you could update your posterior about their political affiliations really well. Same thing about tax break and tax relief. So all these distinctions come from some deliberate effort just to shape the public's perception. One of the prime examples of it, which I took directly from Matt Jensko's slides, is Frank Lunt's memoranda to Republican politicians in the context with Social Security reform in 2006, to not use privatization and private accounts, and instead use terms like personalization and personality. So all in all, what I want to emphasize here is that in textual data and verbal content, we have a lot of evidence that suggests that there is an upward trend in political polarization. What we want to focus on today is non-verbal communication, and in particular, the visual content and data of images that news outlets produce. So just to motivate why we care about visual content, I know for some people probably we need to motivate it, but it helps us kind of like think about this problem more clearly and how it's different from verbal content. There are different accounts from the literature that I'm gonna go over. First, visuals are more memorable, they are processed more rapidly, and they generate stronger emotional responses. Visual content also play, in the context of news, they play a key role in spreading misinformation. This one is a marketing paper on visual appearance, and they show that it affects voters' perception and therefore election outcomes. And perhaps the part which is more related to the workshop on platform analytics is that visual content is particularly more appealing to the younger generation of consumers. So media platforms generally want to get a good sense of how to design the visual content. So in the intersection of polarization and visual content, there are only a handful of the studies that use visual content to study polarization and provide some measures. And none of these papers use the richness and high dimensionality of information in images. So this is the part, this is where our picture comes in. The goal here is to use like the rich information in images to develop a measure for visual polarization. And hopefully by the end of this talk, I provide some convincing evidence that it's important not to ignore the information, the rest of the information in the image. Just to give you an example of this visual polarization, what I mean by it, I took 4 screenshots of articles in CNN and Fox News during the time of the last election. So the first one is an article from CNN, Donald Trump. As you can see, it doesn't look really good in this image. Now, if we go to Fox News, this is what we see. Looking much better. Now, look at the table and look at the other political candidates here. Kamala Harris in CNN, very good picture. And of course, it's a judgment, it's a good or bad picture, but this is what you can see. And the final one you can probably guess where I'm going to. This is Fox News and Kamala Harris. So this is my model-free evidence because the that would be a form of model-free evidence. But of course, I cherry-picked. And but the point is that cherry picking these images, it wasn't very difficult. So you just search and you just find it like in 5 to 10 minutes. So, but the overarching question we're going to ask in this paper is that can we develop a systematic measure for visual polarization? By systematic, I mean something that we don't worry about this concept of cherry picking. And by measure, I mean something that takes this unstructured high dimensional input and maps it into a unidimensional measure. So, and we want to measure. This was based on this again, like model-free evidence. We were hopeful that it's going to be a very quick project. Turns out not to be a very quick one. It has a lot of like challenges that I will walk you through in the next few slides. So here's the research agenda. There are methodological and substantive parts. And the methodological part, the main question, how can we quantify political polarization in visual content? And can we define it such that we have good measures at the politician and news outlet level? So that's that part of the goal. Another sort of sub-question that we ask is that can we extract visual features from the data, like using some off-the-shelf algorithms and use them in some form of like reduced form specification. And you can see that where I'm going with this is that, yeah, it's not going to work really well. I'm going to show you some evidence on that. And another question is about how to validate the measure that we develop. So it's a measurement paper at its core. And this, at the substantive side, basic question, what is the extent of visual polarization and slant that we observe? And how, like, what is heterogeneity across news outlets and politicians? All right, so setting and data, we use SERP API to collect the results of a Google image search for 30 politicians in 20 news outlets from 2011 to 2020. So the politicians are sampled based on their search prominence on Google Trends. News outlets are identical with data by Cliff Flaxman, Charles Howell, and Justin Rowe. And it gives us around 300,000 article records to work with the image, URL of the article, and so on and so forth. One of the big challenges here is you need to clean this data. Like most of the things that we get have like multiple faces, they have like some irrelevant faces or like no faces at all. So we restrict it to images where we only have the intended politician's face. And it gives us those over 63,000 records. So yeah.
Just a quick clarification. So it must have their face, but they can like be doing other things, right? They can be pointing the finger. Or,
absolutely. Yeah.
Okay.
Yeah. But the face should be clear. And that's the only requirement. All right. So just to define the problem, this is the data structure that we have. As you can see, this is the image. So it's an article. Like this is the image by like here, Joe Biden, denoted by ZI. Politician PI, news outlet CNN in this case, YI, and the rest of the information we characterize with XI. Okay, so it could be the title of the article, the year, a URL, etc. So this is the data we characterize just to better understand like how the process we characterize is this news outlet's utility function from choosing an image for an article, which is a very generic form. And there's some idiosyncratic term here. Again, like it's just to characterize it. And our goal here is to measure polarization in a visual feature of interest TI. So this is the first step. Like I said, like there's an unstructured high-dimensional input. You want to map it into a unidimensional thing. That's that unidimensional part. So the one feature, and in this particular case, we're going to focus on smile as the main feature of interest. Partly because we have more consensus based on like comparing to other features, we have more consensus that it's a more positive feature. So, but the point I want to make here is that it's easy to think about other features. So it's just we focus on a smile from here onwards in this talk, but you could think of like any other kind of feature. So now it gives us we characterize two counterfactual versions of the image. One with that feature, one without the feature. So a smiley version of the image and a neutral version of the image, all else equal. So just an isolated change here. And to characterize, yeah.
So by this with and without the smile, the combined best picture and also this would be characterized as without smile.
That's so. I mean, in our measurements later on, we clearly define a set of pictures where there is a neutral version and there is a smiley version. So that image that you are referring to is neither neutral nor smiley. So if you want to characterize this would be a good example. Like for example, this is actually it's not a good example. So yeah, this one is good because like this is neutral, this is a smiley version. So I just to give you the reference of it, like there is a neutral version of it, and then we add the smile as some form of addition. So that was should be the neutral version. But just to characterize
You don't have the opposite of smile, frown.
no, we are just going for this binary smile, no smile. You could think about extensions of it. You could think about different levels of a smile. You can define this gradient, like we add like a little bit of a smile and like it goes twice. So here we have like a very sort of simple binary definition of it. Just a smile and neutral.
There's some within the text part, is there something where you could say like, tough on crime, you're not gonna be smiling when you be kind. And so you'll have some of these heterogeneous categories in which like, it could be very different, but you'll have other ones which are the economy, so like much, right? And then the second one is, are these real photos and are they like, you take one and you create a synthetic?
We create a synthetic one in our analysis. Yes, second question. The first one, we allow for that. So that is, I mean, when I describe the model, that is part of the input. Like for example, upon prime, and in that case, you don't want the primary smiley version is not a very good image to use. The model will pick it up, but it's accounted for in the measure. So this is like here I define this outlet preference for a smile. So all that's equal, just you add a smile, like one isolated feature. Just think of it as just one feature that we can define. Smiley version, neutral version. What is the difference in utility? So one question here is that can we think of this as a good measure of the slant? And the answer is no, because maybe like all outlets, they have some baseline preference for using a smiley version of the image. So smiley images are more engaging. That might be part of their preference. But as you can see, the extent to which one outlet prefers a smile versus another outlet gives us some sense about how polarizing it is, like the choice of this feature is. And this is exactly how we define this notion of this concept of visual polarization. We define it for any pair of outlets And the farther they are from each other, in terms of the preference for a smile, again, this isolated change in a smile, that would characterize our measure of polarization. So the extent to which outlet one prefers a smile relative to outlet two. Yeah, yeah.
Should these be politician specific?
We define it to be politician specific. So this P is for each politician and a pair of.
So you allow for Fox News to prefer a smile from Trump and CNN.
Absolutely. So this is like, if you look at this image, like you could think of this, for example, like if this is CNN and let's say they have this sort of like left-leaning slant, they have a more positivity, they get a more positive utility from a smiley version of Biden compared to Fox. So this is for one outlet minus the other outlet. And you could think of any pair here and any specific politician.
And you can create a measure for each outlet.
For each outlet, each politician. So it's going to be granular at the politician level and outlet level, and pair of outlets.
You're not going to characterize one outlet as being more polarized than the other.
So next point here, if you want to define the notion of visual slant here, so this one that I mentioned is polarization, the two poles of this distribution that we have. If we have something that we can agree on that is neutral, right in the middle, then we can compare everything to that neutral point. The choice of that neutral point is tricky, but in our empirical analysis, that neutral point, the one that we use is Reuters. So, but if we can argue about like what should be that neutral point, but that's what we're gonna use. Ashley.
So I guess I thought where you were going to go with this was comparing the preference for a smile on Biden to a preference for a smile on Trump. And
That is
the
something.
difference we care about for slant.
So here this one is a difference in difference for a specific politician, right? It's a difference in this, like the first one is a utility difference. So difference in difference for this feature. Then you could think about difference in difference in difference. That is like 20 slides from now. You define the notion of conservative visual slant, because if you compare this measure for a conservative minus that one for a Democrat, then it gives you this overall conservative lenience.
But if I want to look at just difference in difference, right? If it's sort of behind the veil, what I would have thought you were going to tell us is that the slant of an outlet is basically going to be how much more they want, like the left plants, how much more they want to smile on Biden relative to how much they want to smile on Trump compared to, I mean, you know, that itself, I think probably be fine.
So here we define this notion of slant for based on the choice of the outlet, right? Like the outlet for any specific politician. Part of the reason is that we want to then show like how polarizing these different politicians are. That measure we will get to that.
I see. So you're not interested in the slant of the outlet, you're interested in the slant.
No.
Polarization of the politician.
Polarization of politician plus the slant of the outlet with respect to that.
I just think.
But for neutral, you might take, I don't know, like an athlete winning a gold medal and then everyone reports on it. Then you might see their preferences for smiles or not. I don't think there's a political slant to it. And that's the neutral. And here you choose neutral as one of the another outlet so it sounds.
So there are many ways we can characterize this notion of slant. I totally agree, and like Ashley's point was also related to this. Here we were kind of like more interested in like having it defined for like one politician, and then we look at this variation across outlets. That makes it difficult to have like that neutral point you're referring to, but that would be an alternative we can potentially consider. All right, so one way to measure this is to use a reduced form approach. The typical, sorry.
Previous slide, I was just thinking, you want to do an overall polarization measure for the public. You could average that first measure that you have, which is politician specific, for all outlets for a given politician. Okay, all pairs of outlets.
Yeah.
Take that average, then you average it over all the politicians. That becomes the overall index of polarization for a given outlet. Okay, so you do the pairwise comparison across all outlets for a given outlet, for a given politician, then do it over all politicians.
Right, but here, I mean, like, one thing we lose is that when you aggregate over all the politicians, it becomes a different measure for polarization. Here, I'm working on, like, we are working with this, and then we are going to kind of develop this measure. You could think of like other, again, alternative ways to measure this, and I agree that there are lots of ways we can characterize it. There are a few different ways that I will show you later in the results. This is not one of the ways, but I will, yeah, we can do something. Just.
Is there a possibility that we can find like some notion of a horseshoe theory in this? So horseshoe theory, kind of like the two ends of the spectrum, are actually in fact somewhat closer together. And by that I mean like maybe both far left and far right have an incentive to like depict, let's say, Biden in a particular way. And then in this case, then they would both be far away from the center, both probably be pretty polarized,
Yeah.
but could also just both prefer a smile. I guess, do we care about that? Do we think that this kind of political space might be kind of more multidimensional as opposed to single line?
We're gonna just measure it. So we're gonna see what we find. There is this possibility that we find that okay, both of them prefer smile, then in that case you don't see any sort of. So but empirically we can see like what this measure is going to be. So, but it's possible, like for let's say, so for some people, it's like both outlets prefer, like all the outlets prefer smiley, right? And you see that in some, I've been showing for some politicians, overall, you see a more positive portrayal, not very polarizing, and that's kind of how they approach it. Yeah, Kiara.
Yes, so what is the objective of this exercise exactly, right? Because one way of using this is, does it confirm my prior,
Mhm.
right? So does it show Fox News on one extreme and, you know, CNN on the other extreme? Or do I want to see it as seeing how polarization sort of changes over time? And so I take a stand that this is a measure of polarization, and then I'm going to. So.
Right. So for this one, the one we want to do is that like, there are we define this measure at the outlet level, we define it at the politician level, and we try to validate it with some other external measures to see like how close they are. I will get to those results later on. The time part, it's actually part of the thing we want to do. One issue is that in our data, the measure of time is a bit of, so we are working on making it more granular. So we, at least for the 10 years of data we have, we can kind of distinguish better. That's the point. But that part of it is the limitation, but something that we could potentially do with the data. And we saw some preliminary patterns that it shows some increase. And you're right that in those cases, it will be more diagnostic, like what kind of measure we should use to be like more apples to apples for different groups. But this is not where I'm going to. So I'm gonna speed up a little bit because I have a lot of results. So just here, there's just to show like this is like one way to measure this is to use a reduced form approach model. Like the first step of it, you extract the feature, like this is f1 of z, z is the image, you extract the feature, like person has smile with the t hat. And then in the second step, you put it inside a reduced form model, the specification that you have. In this case, let's say you regress this smile, like estimated the smile on some function of y and x for a certain politician. So I'm going to talk about like some of the drawbacks of this approach and why we are not using it. First, the puppet has this issue that is characterized as extraction bias by the Maxwell and Malik. It's the concept is that okay, there is going to be some error in your extraction, epsilon1, and this error could capture some other feature. Like it may inadvertently capture something like brightness, if brightness is correlated with more smiley images. So, and then to the extent that it's correlated with the outlet, it's going to bias your estimate. The second form, which I'm pretty sure that this crowd is more familiar with, is omitted variable bias. Let's say Fox News has this tendency to show images that have flags in them, but they have a more like nationalistic readership. And in those contexts, someone is more likely to be a smiley. So maybe like that's not the reason, because the smiley part is not going to be the reason, but you will pick that your model will pick up that as part of the coefficient for polarization. So these two are problems we have with this sort of two-step approach, this reduced form approach. Here, I just calculated this is the omitted variable bias part, that it leads to omitted variable bias. This is the extraction bias, and this thing also, like in your extraction, you induce some noise. It could be fully random, but it contributes to a higher variance of your estimate. We do this, and we perform a very simple empirical task on images of Hillary Clinton. We use that reduced form approach. I'm not going to show you the results of it, but what I'm reporting here is that both the and we use it with and without some arbitrary visual features like brightness, contrast, edge density, etc. And the thing that we see here is that the coefficient changes in terms of magnitude and significance. So just by some arbitrary features that I added, you could imagine that the extent of it could be much larger or even smaller. The point is, we need an approach that kind of systematically uses all the information in the image. We don't throw out the rest of the image and only we shouldn't extract just the feature of interest. So here I'm going to talk about our algorithm, and yeah, I'm going to be again like a little bit quick, but we will get to the results and discuss some of those results. So remember, like this was a definition we had. We said, okay, there is this preference for a smile for one outlet versus another. Like how far they are from each other. This is the notion of polarization that's we already have. So yeah, you can think of this as CNN, Fox News, or any other pair that you have. One challenge we have is this counterfactual image generation. We need to generate these two versions. Back to Sridhar's question earlier, we need a set of images to work with. The other part of it is this, like identification of this whole thing is going to be difficult because I only observe the article that is produced. I don't observe the choice set with the news outlet. So that's part of the limitation here. So for the first part of it, we use conditional GANs, which is used recently in econ and marketing papers. The idea is to just add this isolated change in terms of a smile, like you see the neutral versions and the smiley versions. And we perform some statistical tests to make sure that the change is only in a smile, like other visual features do not change. Of course, an exhaustive search here would be very difficult. If you have good suggestions how to kind of ensure this just isolated change, please let me know. So that's this part for generating counterfactual images. For each politician in the test set that we want to measure these things, we have 3 pairs of neutral and smiley images. Then for identification of our polarization parameter, we have this empirical analog that we can write down for like any politician and any pair of outlets. So we can define it as such. The issue is unobservability of the choice set by the news outlet. The way we kind of think about this problem is that we move this goalpost to we reframe it as a news outlet prediction problem, something that we can actually do. We can learn some good models in that task. And here, so this was a difference in utility from a smile between 2 outlets. Now we define it for the smiley version. What is the log odds ratio of this being produced by one outlet versus another, minus the log odds ratio of the neutral version by one outlet versus the other. Where does it work? Like, what do we require here for it to work? If we have enough variation in things like similar events, like this is for the operation bar with speed, you see like all these outlets, they covered it, but they use different images for it. So the underlying explicit assumption that we have here for something like this is that all these outlets, we assume that they have the same, by and large, the same choice set, and they choose from that. So we require that, and that's and we do lots of like sensitivity tests here, but this is the idea that we transform the problem into a prediction task. Now, how the details of this, I should go a little faster. So we add these resonance features to capture the contextual aspect of the image, like the operation bar speed, like the similar events and so on. And we have these face VGG features as layers here, so we can capture the smile, and I will show you some results. And we add the categorical inputs on date, politician, affiliations, text, etc. So we train this news outlet prediction model. And this is the first step. We have these counterfactual images, pairs of counterfactual images for each politician. And this is the training part of it. We train a prediction model. And in the final step, you feed into the test data, you use these estimates to measure visual slant for like you can define at the article level and then aggregate it for all the articles of one politician. And you here again, as I said, we compare it to Reuters as the baseline. If you have other suggestions, it's also easy. Everything is analytic, so it's easy to kind of move the baseline to something else. But Reuters, I think we just used it because it seemed like more reasonable. So now we get to empirical results, and I have good few minutes. So
Yeah, just one quick one. I would imagine we talk about choice of images, but there are also choices for titles. And all the titles that are shown in the outlets are like selective, is not representative enough. And if we just sum over all the samples we got, we probably, I don't know what the result would be because maybe the title is polarized as well.
right, and we control for the title in the prediction model. So the input about the title goes into the prediction model. So the prediction of the image, like what is the how much more likely one outlet is versus another one, is going to be with respect to this textual input that we have about the outlet. All right, so on the predictive side, model training is a multi-class classification problem with 20 labels. These are 20 news outlets. We do a 85-15% train test split, and we use different sets of features just to illustrate the performance, how it performs. So the first thing I'm going to report here is that the model, the full model, like with all the features, like text, image, and like all the categorical inputs, it achieves close to 44% accuracy, which is very high if you think about having 20 different outputs. Like if you do the task yourself, you see how difficult it is, and just put it in perspective. A random gets 55% accurate, and 43%. And also, like again, another thing to put in perspective, if you go head to head, like one outlet versus another, it's over 90% accurate, like in terms of predicting which outlet produced the article. Another thing is that the image input seems to be very valuable for this prediction task. So the performance goes from 16% accuracy to 43%. So there's a huge jump here, and it is not obviously all attributed to slanted preferences for images, but we know that the information in the image plays a big role. So now, just to see how the model works here, we use grad camps to see like where the model pays more attention in predicting the outcomes. So these are two versions. Again, like this is a original version of this image by Trump, and there's this is a smiley version of it. And as you can see for the resident features, it captures, like here it's like the heat map is, it shows that it kind of like it pays more attention to its operation warp speed. This is the event that it tries to kind of, it captures the information for. And then when you look at the face PGG, the facial features, you see that it, for example, in this case, it clearly captures that the smiley component. So this is just a piece of evidence to show that it's kind of like, it passes some of the sanity checks, that it kind of like takes the contextual features as well as the facial features. Then for detection of similar events, we do this image clustering for images of Trump. We use this embedding of all the images. We map it into 2 dimensions. So of course, we use a lot of information. It's not in our analysis. It's just to illustrate the point. You see this clustering structure. We zoom in one of these clusters, like again, like it's set up like some similar events. As you can see, it's covered by different types of outlets. Here is kind of the conservative share based on other measures, not used again in the model, but based on these other measures, it is kind of like different outlets use that reported this particular event. We zoom in even further, and I want to just show you how this approach works. Here, for example, these are 4 images that I showed you earlier on coverage of Operation Warp Speed. So Daily Mail, Washington Post, Newsmax, ABC News. We have 4 different images, same event, Now we take this one, Washington Post, it's here, and we add a smile to it, and we want to see where it moves in the overall embedding. As you can see, it moves from here to here. It gets closer to instances from Daily Mail and Newsmax. If you look at the predicted probabilities, what you observe is that so the probability for Washington Post before on the test set was 31%. After adding a smile, it becomes 3%. On the other side of it, for Daily Mail, it goes from 3% to 21%. For Newsmax, it goes from 7% to 16%. And for ABC News, it kind of remains relatively unchanged. So this is just one instance again to illustrate that how this addition of a smile changes these predictions and how it will be captured by our model. If you want to do it more systematically, we can think about this distribution of visual slant across like articles, like we have the numbers, and we can visualize them. So we focus on a subset of outlets based on their leanings, and based on other measures, external measures. For Republican leaning outlets, the measures we had among the 20 outlets we had, these were like Fox News, Daily Mail, and Newsmax. So this is not our measure, this is external measure. No information about that is used in the model training. So the model is blind to that information. We just want to use it for illustration. This is Democratic leaning outlets, Washington Post, CNN, New York Times, and the baseline, as I said, is Reuters. The first one is for the set of Republican politicians we have in our data. So this is a distribution of visual slant. The red one is for the Republican leaning outlets, and the blue one is for Democratic leaning outlets. As you can see, there's a clear sort of divide between both. So Republican leaning news outlets receive a higher utility from a smiling image of a Republican politician compared to Democratic leaning outlets. The pattern reverses. If you focus on Democratic politicians, now Democratic leaning outlets, they prefer it more than the Republican leaning outlets. So this was just to illustrate for these outlets, we can define the measure at the outlet level for Republican politicians and Democratic politicians. It goes back, it gets close to Ashwin's question earlier. So this is for Republican politicians. You see, for example, Daily Mail, Newsmax, they have the higher slant measure, and Washington Post and CNN are on the more negative side. For Democratic politicians, USA Today, New York Times, Washington Post are among the higher values, and Daily Mail, Fox News are the lower. There are some outlets that you observe, like Wall Street Journal, CBS, and for them you see that for both candidates, for both politicians, like Democratic and Republican, they have a relatively positive number relative to Reuters. Again, there are a lot of differences. You have to keep remembering all of those, but this is, for example, like Wall Street Journal, positive here and positive here. Now we think about that measure, like I mentioned earlier. Let's take the number every outlet has here on Republican politicians, subtract it from the one on the Democratic side. It gives us a unified measure, and this is what we define conservative visual slant, and this is just one measure for the news outlet. What we see, Daily Mail is the most polarizing, the most conservative, has the highest conservative slant, Fox News and Newsmax. And on the other side of it, Washington Post, USA Today, and New York Times. So this is kind of the range that they find, and there are some outlets like Wall Street Journal, Reuters is by design, obviously, CBS News, again, a very low amount. So this is what we find here for this unified measure. Now, how much time do I have? 5?
2 minutes.
6. Okay, good. So now we want to validate the measure. We want to see how it correlates with existing measures. There are some existing measures from, they don't use the visual content. They use other forms of input. So we correlate our measure with the one in Faris et al., Flaxman et al., and all sides. There are 3 different measures. We see a very high degree of correlation between our measure and those. Another form of validation, there is this other paper that focuses on visual slants, the closest one to us, but uses this reduced format approach that I described earlier. I didn't have time to kind of go into the details of that, but That paper also has some measures at the output level. We want to compare like how, whether our method is closer to like external measures or that one. And we see that our method is, it's like, for example, the Pearson and experiment correlation is much higher. And in this case, there is a slight correlation, but it's not significant. Of course, we don't have many instances in in our data, but overall, we see that there is a higher correlation with our measure. Now moving to politician-specific part of it. So for each politician, again, you can see the dispersion across outlets. So here for Barack Obama, Donald Trump, you can see like how the variation. I skipped this, as you see, again, like similar to the earlier story, with little bit of differences here and there. But overall, like, there are some outlets like Daily Mail, Fox News, Newsmax on the right side, and Washington Post, New York Times on the left side. And it's pretty much consistent. Of course, there is some degree of difference. What we want to do again, can we define a unified measure at the politician level? The way we define this is that we intuitively expect a greater variability in visual slant measures across outlets for a more polarizing politician. So if the politician is more polarizing, these scores they have higher variation. If they are less polarizing, they are kind of like centered around the number, and they don't exhibit a lot of variability. So this is the standard deviation measure that we define, and here is the result. So the most polarizing figure, not surprisingly, Donald Trump, Barack Obama, Bernie Sanders, Hillary Clinton, Kamala Harris. So on this side of it, kind of expected. And expected is good, like we don't want something counterintuitive necessarily here, it's a measure. And on the right side was the part I was more excited about when I got the result. You see Susan Collins, Liz Cheney, Joe Manchin on the right side of it. That's a less polarizing political figures. So we're all known for like some level of like bipartisanship. So you see that they are represented on the right side of the graph. How can we validate that? The validation measure that we have here is the politician's ideological alignment. We don't have like very good measures, or if you know some, please let us know. We will incorporate it. But the one we used here is that just based on some intuitive reasoning, politicians' ideological alignment with their primary constituents. And the idea here, so the way we measure is party's percentage point advantage in the politician's state in 2016 election. What is the idea here? What is the intuition? There is a higher cost of being polarizing in an ideologically incongruent state. So if the state is like, if you are a Democrat in Kentucky, it's much more costly to be polarized. So we use that measure on the x-axis. We look at the correlation, and there seems to be that the correlation is pretty high, like on both. And you see that, for example, like someone like Joe Manchin is a prime example of this. A person in a red state, Democrat in a red state. So as a result, they don't have that much degree of freedom to be more on the extreme side. So this is the measure we use here. Again, we are happy to incorporate other measures. This was just kind of intuitive to us. We use it here. Finally, in conclusion, this is the paper has like two types of contributions. One is in terms of like proposing this algorithm or measuring visual polarization with respect to a certain feature. Of course, we focus on one feature, but you can extend it to other features. And the idea is that we combine GANs with this sort of underlying utility model, and we try to kind of capture the rich information in the visual content in our measure. The framework itself is applicable. You could think about applications of it broader than context, broader than political polarization. And in terms of substantive contributions, one is just demonstrating this extent of polarization visual content across media outlets, and the overall like underlying heterogeneity across outlets, across politicians. And with that, thank you very much.
Actually, changed the slides slightly while we were presenting. I realized I made a mistake.
That was smiles.
How do I, All right, thank you to the organizers for asking me to discuss this paper. I think it's a really cool, really exciting paper. Really excited to talk about it. I know I'm the only thing standing between everybody and the glide report, so I will try to keep this on the shorter end. Okay, so just to kind of talk about some things that I like about this paper. First, it's addressing an important topic. We saw 2 talks just now that talk about polarization and how important it is, and I think we're all very cognizant right now of the real world implications that our current politically polarized environment can have. For instance, the fact that all of our stock portfolios have fallen about 15% in the past few days. So, you know, really important stuff here. Conceptually, the paper is taking a novel approach that I think is building on a lot of different sort of disparate literatures. So, Omid talks about the papers that look at political polarization and things like that. There's also a growing literature that looks at measuring bias and polarization in images more generally. For instance, there's this paper by Gilbo and co-authors in Nature last year that looks at gender bias in images online. So there's a lot more research that's starting to emerge looking at images and video and other types of multimodal data. And there's also more and more research that's looking at estimating flexible machine learning models and then conducting ablation studies on those models in order to assess counterfactuals. So this paper is also building on that literature that's kind of using these very flexible machine learning models in this way. And I think one thing that's really nice about the paper is it's very thorough. So if you haven't read the paper, it's 70 pages long, it's very dense, very detailed. And so I think they do a pretty good job of dotting their I's and crossing their T's in terms of probing the performance of the GANs that are used. So we briefly talked about the test to see that the images are not being altered in any way beyond the smiles being changed, and also just being really thorough and rigorous in terms of comparing this new measure of polarization to pre-existing measures of slant and polarization, both those that are also image-based and then others that have nothing to do with images. That being said, I wanted to spend a little bit of time talking about 3 broad areas where I think there is room to either improve the paper or to maybe build on the paper and push it into new directions. So one is just thinking about the utility framework that's underlying the entire paper. So we mentioned that the paper models each outlet's utility as this very flexible function. That's basically a function of the image that is selected, so that's the I, the attributes of the article, so the text, the title, things like that. Xi, the politician being covered, P, and then the outlet itself that's covering the particular politician in the story, Y. The approach is very flexible, but one thing that it doesn't explicitly account for is other publishers' choices of text and image for the same event that's being covered. So if we think about classic hoteling style models, you can imagine that all of these outlets are in a simultaneous game where they're choosing where to exist in this sort of polarization spectrum, right? So you can either be far on the left or the right-hand side here. This is kind of counterintuitive to normal political language. But here on the right, that's very blue, and we've got frowning Donald Trump. And all the way over on the left, we've got smiling Donald Trump. And so, this might be something to explore. It might make the sort of mapping from utility to predictive modeling a little bit more difficult, but I think there's some interesting potential here. One thing that you could do with this is to think about how the utility framework can be used to, sort of ex post, think about a lens to interpret the paper's results. So if we have this model in mind, if we see where different outlets kind of land on this polarization spectrum, maybe we can fit some sort of model to understand what that competitive game is. And then we can use that model to perhaps evaluate different policy counterfactuals, right? So something about copyright, something about what types of images different outlets can or cannot use. So I think there's some interesting potential here to just think about the utility framework and whether or not it's modeling the underlying dynamics in the right way. Another thing to think about is just some of the sort of like nits in terms of all the technical machinery that's going on. I think you can probably tell from the talk that this is kind of like a really impressive Rube Goldberg machine of different machine learning models that are being put together. And so there's a lot of researcher degrees of freedom in sort of how this is done. One thing to think about, I think, is how we can be really sure that the GAN is not making alterations to the image beyond the alterations that we want to be making. So in this case, whether or not the focal politician is smiling. These are the sort of tests that Omid referred to during the talk. So in the paper, they look both at the brightness of the image and the colorfulness of the image. And they sort of compare the histograms for these two different measures, do a Kolmogorov-Smirnov test, and make sure that these distributions are the same. And in fact, they are. That's a pretty good test. But as he mentioned, this is by no means comprehensive. And there are a lot of ways that these images could be altered that might not be picked up by this test. So for instance, I went into GPT-4o earlier and I said, take this photo of Donald Trump, add a smile, try to keep the brightness and the color exactly the same as the original image, but make a very conspicuous change to the model or to the image nonetheless. And so we have big-eared Donald Trump, who would not show up in those Kolmogorov-Smirnov tests, but nonetheless, it's really different, a really different look for Trump. Another thing to think about is whether or not all of the publishers are actually selecting from the same set of underlying images, right? So this was mentioned during the talk, and in the paper itself, the authors say, despite being captured from the same event, these images present Trump in a bunch of different ways. And so for these events, under the assumption that all of the outlets are selecting from the same set of images, you can get this identification. But you can imagine that there are many cases in which the outlets might not all actually be choosing from the same set of images, right? So I did some research, there's New York Times specific reporters, the AP has their own photographers, Reuters has their own photographers. And so the New York Times, for instance, might, as a policy, not be selecting from the Reuters or AP photographs. And other news outlets might have similar policies. So how might that affect the the stability of the estimates that are sort of extracted from this method, and sort of can we put some bounds on what we can learn based on the possibility that the image sets are not entirely overlapping for the different publishers. I think that one thing to think about for this particular issue is that it's possible that the machine learning model that's being used to predict the news outlet based on the photo can itself kind of learn this without having to model it explicitly, right? So if there is a photographer who only takes photos for the New York Times and they have a particular style, that might just get learned by the model, in which case this is not a concern, but I think it's worth digging into this and kind of understanding the extent to which it is or is not happening. And then the last thing I want to talk about is kind of possible extensions and interesting directions for this work. And I think one thing to think about is the extent to which, or sort of like, what do we actually learn from this image polarization exercise? And I think this goes to Kiara's question during the talk, sort of what are we actually doing here? So in the paper, they show that this new measure they have is very highly correlated with a number of existing measures. So over here on the left, I'm showing this disparis conservative score. Notably, this score has nothing to do with images or text. It's about reshares on Twitter and whether or not the resharers tend to be Republican or Democrat. One thing that you could ask is this measure as highly correlated with some of the existing text-based measures? So for instance, the Jenskow and Shapiro measures of polarization from text. This comparison is not really currently done in the paper. And if we do see that there are some deviations, can we somehow use this measure in a more interesting way, right? So suppose that there are certain outlets that are very polarized when it comes to text, but not to images, very polarized with images, but not with text. What does that teach us about how these outlets are thinking about these different types of media and how they report on them? So I think there could be something kind of interesting to look at there. I also think that it's interesting to think about how this approach can be applied to other contexts and other types of image discrepancies, which Omid mentioned in passing at the end of the talk, right? So for one, the paper focuses on this very particular measure of polarization, which is whether or not a politician is smiling. And I think it's a pretty good, well-justified summary statistic of what valence the politician is covered with, but there's presumably much more that goes into how polarized an image is. So for instance, you can think about looking at image brightness. This is taking that same image of Trump and just making it really dark. And I think we could all agree that this bottom image has a much more like ominous, dark tone to it than even this top image, which is not very flattering. Also, you can think about the same policy or the same like method and measure being applied to other contexts outside of politics. And I think especially being that we're at a workshop on platform analytics, there's a lot of interesting platform questions that could be asked using this method, right? So we think in the context of advertisers, perhaps advertisers are all selecting images from the same set of stock photos. Are there certain biases in terms of which types of images different advertisers choose when they're selecting stock photos? Do different platforms tend to choose different types of images? When influencers are posting about the same events and choosing which photos online to use, do they have certain biases? So there's a lot of platform related questions that we can maybe apply the same framework to go beyond just questions about political polarization. One thing to note, one obstacle here is this requirement, this identifying assumption that there is this shared candidate pool of images. And so at least right now, that kind of restricts the set of questions that this framework can be used to answer. And so this is another reason why I think sort of thinking about what happens when that candidate set of images is not entirely shared between the different entities is quite important. So just to quickly wrap up, I think this is a really cool, really impressive paper. I'd highly recommend reading it if you haven't. The paper is also super long and super dense. And so I think that sort of leads into my second point, which is right now, I think the paper is kind of caught between being a methods paper and a paper that's trying to say something substantive about political polarization. And so I think choosing one of these lanes and kind of doubling down on it might be sort of a wise move. So I think all the technical stuff is in and of itself super impressive, but then the polarization stuff feels maybe a little bit tacked on. Alternatively, if you want to focus a lot on what we're learning about polarization, maybe it's less important to focus on a lot of the technical details of the method. And I think there's just a lot of really interesting directions to take this work. So I think either of those paths are entirely viable, or I think you could build on this and answer a lot of different questions. So I'm super excited to see how the paper evolves. So that's all I had. Thank you very much.
So thank you very much. Like all the comments were great. I wrote down a few things here. So the competition dynamics certainly like it's a very sort of interesting direction. In general, like some of the theory insights we have is that like whenever you introduce like some of the competition, there is a higher tendency to become like more polarized and differentiated. In this particular case, in one direction I'm thinking of, and we had like some limitation that we discussed there, but is to kind of like see what is the source, like what, and to the extent that it's kind of like this is played simultaneously and they don't have access to the other outlets, images. Some of it is captured in the predictive model, but then if you want to kind of like think about, because we have, and David mentioned that like if you want to kind of include like other images, then it kind of like it screws up the performance of the predictive model. So there is like some inherent limitation there. So it's we have to be very careful in like how we want to incorporate competition dynamics, but it's a very interesting and promising direction. For some there are like some weird things that change also in the image. I think we need to do, if you have like really good suggestions in general, like I'd be more than happy to hear that. There are like, we can extend like the amount of like tests that we run in terms of making sure this is the same sort of images. For sure, we're going to incorporate that. We're going to see like what is the correlation with the 3D textual version of media slant. I know that those measures are correlated with the three measures that we included here. The chances are very high that it's going to be like, again, we see a high degree of correlation. And for the extension to other cases, like here, one limitation we have is that we need to make that assumption that the choice set is the same, which is kind of like, oh, in the data point of view, like we see that the vast majority of images are taken from Associated Press and Getty Images. So that's, but definitely we will dig deeper into like some specific cases and to what extent the model will capture that. If when I extend it to other platform settings, maybe like one direction is to kind of just record the food choice. So if we have the food choice set, like our lives will be much easier. So that would be an easier way of like applying this. But in that case, maybe like also the algorithm will change so much. In summary, thank you so much for the comments. Like it's very helpful, and thanks again to the organizers for this great conference.